When I was a kid looking up at the stars, I really always wondered, how did we get here? And are we alone? My name's Bethany Ehlmann. I'm a professor of planetary science at Caltech and research scientist at the NASA Jet Propulsion Laboratory. I remember when I was 6, I declared that I wanted to be an astrophysicist like Stephen Hawking. And I'm not an astrophysicist, but I am an explorer of planets, of asteroids, and I really enjoy the unknown in space exploration. We're going places that really no one has gone before, and it's one of the few types of science where you can do that. Our solar system is about 4.5 billion years old, and asteroids formed within the first few million years that the solar system existed. Asteroids are mostly metal and rock and ice, and are thought to be the shattered remnants of planets. They're these bank vaults full of information about what conditions were like early in the solar system as planets were forming. What we're looking at here is the largest asteroid in the asteroid belt, and we're able to have this amazing view because of the Dawn spacecraft mission, which orbited Ceres for several years.
2, main engine start. 1, 0, and liftoff of the Delta II rocket with Dawn.
The Dawn mission was a spacecraft that was launched in 2007, and it was designed to study Ceres, which is the largest asteroid in the asteroid belt, and it's actually not just an asteroid, it's a dwarf planet. One of the most fascinating things about Ceres that we discovered is it wasn't a uniform gray. Some parts of the surface had these amazing brighter spots. Here you can see one of them coming out of the crater. This was totally unexpected. One of the fun parts of being a planetary scientist, and especially my job, is that I have a laboratory where we get to measure the spectroscopic signatures of rocks and minerals. Every material has a characteristic way that it reflects light. We can call this a spectral signature. And so one of the things that we can do is here on Earth, we can measure the spectral signatures of all sorts of materials that we know exactly what they are. And then we can compare those signatures to the reflected light that we get from asteroids to figure out what those objects are made of. Now on Ceres, we basically repeat the measurement, but our spacecraft is the sensor instead of my lab instrument, and the source, instead of a halogen light in the lab, is the sun. And so by comparing those materials in the lab to the materials that we see on other planets, that's how we know what planets and asteroids are made of. When we looked at the data, we found that these bright spots were actually made of salts. And these salts were being pulled up by impacts. So salts underneath the surface of Ceres, what did that mean? That meant that there were salty waters underneath Ceres at some period of time, maybe even a salty ocean deep underground. What past underground waters tells us on Ceres is that Ceres was once wet, and because other asteroids are like Ceres, water rich, that tells us that some of the asteroids that were hitting Earth early in its history were probably delivering some of the water that's found on our planet today. One of the key questions about asteroids is, did they play any role in the origin of life? Asteroids brought water and carbon, some of the most important ingredients for life, to our planet very early in its history. Did they help make Earth this amazing habitable place it is today? We don't fully know the answer. We think they played a role, but that's one of the things we're trying really hard to figure out right now. So these are some of the reasons that I explore, is curiosity and a desire to learn things that no one yet knows.